Hey guys, so here's part 2 of the 1.1 notes. We are now going to graph quadratic functions in standard form. So the first part that we always want to do in graphing is we want to determine the vertex. There we go. So remember, to figure out the vertex, we need to solve for our x. Now what I like to do is indicate what's our a value, what's our b, and what's our c, okay? Now remember, a is the number in front of the x squared, that's going to be -1/2. What about our b here? Oh, it's going to be 0. And then what about our c? That's going to be 3. So be careful, because notice we are missing the middle term, okay? So we have x equals opposite of b over 2a. Our opposite of b is just going to be 0 over 2 times -1/2. And basically that will just give us 0, because anything 0 divided by anything, that gives us 0. Okay? Now to find the y value, we plug 0 back into the original equation. So y equals -1/2 times 0 squared plus 3. I get 0 plus 3, which gives me 3. So my vertex is 0, 3. Okay, next, let's talk about the axis of symmetry. I call it AOS, just for short. Okay? So remember, make sure it is an equation, so you need x equals. So for axis of symmetry, it's always going to be the x value of our vertex. In this case, it's 0, so the axis of symmetry is x equals 0. Okay? Okay, our next thing is going to be graphing. Now, before we're going to do that, let's go ahead, let's talk about maybe some of the transformations here, just so we can get a clear idea of what's going to happen, okay? Okay, first thing, does this have a reflection? Well, notice that our a value is negative. So yes, there's going to be a reflection, meaning that this is going to be opening down. Okay. Is there any vertical stretches or shrinks? Yes, if we take the absolute value of -1/2, that gives us 1/2. That is still less than 1, so that means we have a vertical shrink. And it's 1/2, and that means our graph is going to become wider here. So we're just kind of going back some of the old information that you guys learned about transformations. That's going to be continuous throughout this AS Algebra 2 course. So make sure you remember those transformations there. Okay, now I'm going to go ahead and graph. So I need to plot my points. In order to do that, I need to create an XY table here. So this is how I'm going to graph a quadratic function in standard form. My vertex is going to be in the center, so it's 0, 3. I'm going to pick 2 x values that are smaller and 2 x values that are bigger. So smaller would be like -1, -2, and bigger would be 1 and 2. So now, in order to do this, just plug these x values back into the equation. So like you would plug -2 in for x, and then we square it, times -1/2 plus 3. So make sure your order is correct. So we'll kind of go over this so you remember. So we have -1/2, -2 squared plus 3. So remember, when you are doing this, order of operations. So we actually do exponents first. So we do -2 squared. That gives us 4. Then we multiply by -1/2. So that'll give us -2 plus 3, which gives us 1. Okay, we do the same thing on our negative ones. So I have -1/2, and then -1 squared plus 3. So I do the exponent first. -1 squared is 1, multiplied by -1/2. That gives me -1/2 plus 3 gives me 2.5. Okay? Okay, let's see what we get for the 1. So we get -1/2 times 1 squared plus 3. So if I do this, 1 squared is 1 times -1/2 plus 3 gives me 2.5. Oh, that's interesting. Okay, let's try the last one here. So I get 2 squared, which gives me a +4, times -1/2 gives me -2 plus 3 equals 1. What do you notice about the y values? They repeat. This is similar to our absolute value functions. So the y values repeat. And the reason being, as I'm going to graph these points, you'll see that we're making a U shape. So when we make a U shape, the Y value should repeat. Okay, now let's go ahead and graph these points. So we have 0, 1, 2, 3. Now remember, which way are we going to open? It should open down. So I could go to -1 and +1, go up 1, 2.5, and then 2, 1, and -2, 1. Now make sure for this one, you get a curve. So with absolute value, there was like a sharpness. It was very sharp, like a V. But with quadratics, it's going to have a curve to it to make a U shape. Okay? There we go. Now, one thing I want to talk about is the y-intercept. Okay? So y-intercept, what does that mean to you? Well, the y-intercept is basically where the graph crosses the y-axis. Here, we can clearly see from the graph where it crosses, okay? But what if we wanted to just use our equation? So we know our y-intercept here is going to be 0, 3, because that's where the graph crosses the y-axis at 0, 3. But notice here, if we actually put 0 in for x, whatever the c value is, that's going to give us our y-intercept. So without even graphing, you always know what is your y-intercept by knowing that it's always going to be 0 and your c value on the equation. Okay, so that's just something that'll help out whenever you're graphing. Okay, let's go ahead and try the next example. Okay, actually what I would like you to do is go ahead and pause the video and try this on your own. Okay, let's see what you got here. Let's find the vertex. Okay, our A value is 2. B value is -8. Don't forget to bring that down with you, and we have 6 at C. Okay, the vertex, we got x equals opposite of b over 2a. Opposite of -8 is actually +8. We have 2 times 2. We get 8 over 4, which gives us 2. We plug that back in to get our y. Make sure you do the orders of operation. So we do 2 squared, which gives us 4 times 2. That's going to give us 8. Minus 16 plus 6. And so that will give us a -2. Now let's think about our axis of symmetry. AOS. Remember, it is an equation, so you need to have x equals. And that's going to be the x value of our vertex, which is going to be 2 here. Now let's go ahead and do this next part. Let's talk about the y-intercept. Remember, that's going to be 0 and whatever the c value is. In this case, it's going to be 6. Now let's kind of just list maybe some of the transformations here. Okay, what is our A value? Is it positive or negative? It is positive, so we are going to open up, meaning there is no reflection. Okay. And do we have any vertical stretch or shrinks? Yes, we do. We actually have a vertical stretch. Because the absolute value of our A2 is just 2, and that's greater than 1. So that means we're going to have our graph to be a little bit narrower than the parent function. Okay, now our next thing is to do our XY table. Don't forget, your vertex needs to be in the middle. So we have 2, -2. Now pick 2 points that are bigger, 2 points that are smaller. So we'll have like 1 and 0, 3 and 4. Now remember, your y value should repeat. So really we only need to solve for 0 and 1, and then 3 and 4 will just repeat. So we plug 0 into our equation. Which of course that was our y-intercept. Then we're going to plug 1 into there. So we have 1 squared, that's 1 times 2, we get 2. And then we get 2 minus 8, that gives us -6. And then plus 6 gives us 0. So then, to reverse it, we should have 0 and 6 here. Okay, let's go ahead, plot these points. I like to start from the vertex, so we go to -2. And then we have 1 and 3 at 0. Notice where they cross. Here they cross at the x-axis. And pretty soon we'll talk about x-intercepts. So that's basically where the graph crosses the x-axis. Then we have 1, 2, 3, 4, 5, 6. And that's going to be the same here. And we connect the points. Don't forget to do that. Don't forget your arrows at the end. Make sure it's a curve like a U. And remember, our axis of symmetry, which I didn't draw this on the last one, but that's okay. Axis of symmetry, it is a line that goes straight through our vertex. So that's why we say x equals 2, because it is a line that goes through our vertex. Okay? And then that's basically it for this one. Okay, make sure you watch the last part or the last video for 1.1. There we're going to be talking about word problems.